What's going on, y'all? Welcome back to the madness. Today we're going to be doing another Axe Effects tutorial, and this time it's going to be on the phaser module. Phase in and out a little bit. We were doing a little bit more of the tone hunting kind of series, but now we're going to take it right back to roots and teach you guys some more about the phaser. So let's jump right in before it gets too long into this thing. Alright, so here's the deal. We've got basically a phaser module right here, and it's got a bunch of different types. I'm not going to go too far into the types because you can find your own ones that you really like, right? But I am going to go through each of these individual knobs like I have in every other tutorial and tell you what they're all about and kind of demonstrate a little bit on my guitar. I made this preset called the Smokin' Crickets, which is apparently a comp-driven dual amplifier quadruple cabinet mixed up into a pitch shifting, which is an octave divider, mutated phase, and a reverb. So I'll give that a demonstration. Everything is constant as far as like changing your tone over time, except for the phaser and the reverb. But the reverb it's not as prevalent as the phasing. So here, give it a listen. I'll play a little riff for you. Alright, so that's that. So let's jump into the phaser and its different components. So first off, we've got two different tabs here. One's a phaser tab, or the main phaser tab, and then the more tab, which has a couple other pieces involving this type here. So we'll get to that later, but we'll start off with the rate. The rate is how fast it sweeps the frequencies from left to right within a certain band, right? So if you per se got your minimum frequency at 131.5 and max at 3701 like I've got here, it sweeps from that frequency to the other frequency. And then how fast it does it is the rate. So it goes every 1.291 hertz. So that's what's going on there, okay? The tempo is essentially the same thing as rate, except you can choose, quarter, dotted, whatever type of note you want, but then it's only one or the other. So let's demonstrate rate real quick. Let's increase the mix to make sure that you're hearing it. So that's what's going on. Okay? So let's go on to depth. Depth is how deep within these two frequencies, how pronounced it's sweeping. Okay? Let's show you what it means, or make you listen to what it means. See how it sounds like it's kind of like in the center. It's not really fluctuating too much. As you increase it, it becomes more and more prevalent. That's what's going on there. Feedback has a couple different names that people have called it. In the notes I show here, it says resonance, regeneration. It kind of gives you that traditional, iconic phaser vibe, right? So we can give you a listen on what that kind of sounds like, right? Negative feedback. A little bit more so. As you go into positive. Now you notice the difference between like one has a more airy kind of feel, right? So adjust it as you like, but that's what's going on there. Onto the manual knob. So this one and the depth one kind of work in conjunction. What's going to happen is if the depth is all the way to 0, it's controlled completely by the manual knob. And if the manual knob is all the way to 10, it's controlled completely by the LFO. So this is what's going to happen. If I were to play a chord like I've been, and I use the manual knob, you manually sweep it from its max to its min frequency. Okay? So, but if I were to change depth to 0, it's going to use the manual knob 100% to control the phase. Now I'll bring depth back up. If I go to manual up to 10, now it's being controlled completely by this LFO here. And that's what's going on, okay? So that is what the manual and the depth knob are doing. Let's talk about law and order. This order parameter here is going to tell you how many circuits it is using in order to create this phaser effect. So each one sounds pretty different, but I think the further you get down, the more drastic the phasery kind of sound is. Let's just start at 2, work our way down. I'll play the same lick over and over again using each one of these. That's that. Let's jump on to the next. The min and the max frequency are where the frequency is shifting to. Per se, it's at 3,000 here. If you want, you could have it shift all the way to 5,000, sweep all the way down to wherever the low frequency is. It's just going to change the sound of the phasing. I can show you this real quick. Went all the way down to 5 hertz, all the way up to 20,000 hertz, right? If I increase the depth, it's going to go all the way up there. Notice it's not going down as low anymore. Not as high anymore. Right? Now it's just kind of in this like middle ground, kind of mids. Kind of gives it that dark, almost Terminator type sound, right? So let's get this back to normal. Alright, on to the next. Let's talk about this LFO. Alright, so what's this LFO doing in our phaser? It is important because it is determining the characteristic sweeping of our frequencies. So, per se in the saw up type, you're going to hear that it goes up in frequency and then abruptly drops, right? And that's the deal. In this little picture, you can imagine the frequency is on the y-axis and the time is on the x-axis, and what it's doing in here is going to determine what happens. It's the characteristic sound, right? Log could be, it starts high in frequency, it goes down quickly, comes back up, stays up for a while, and it does that sort of thing. The phase is basically going to change how it starts and ends, right? So I'll play a little bit of a note for you. You can kind of hear the difference. I'm not going to go and give you the mathematical definition of phase because it's just too boring. Alright, let's change this back to 6. Now this is actually what I've put in here. Put 180 degrees and an order of 6, and you've got the reverse sync kind of effect. And that's what's going on there. The high cut, you're basically removing sharp transitions from these types of signals. So makes sense for you. The quantized portion, when it's off, you're just kind of sending the LFO as like a straight, like continuous sample. When you quantize it, you're breaking it into pieces, and so basically at the lower numbers, it's much more obvious. Off. 2. as the number gets higher, the smoother it gets. So you go up to 16. For the astable beta, this is one of those parameters that it supposedly changes the contour from more triangular to a squarish. But I mean, I'm sure it's noticeable to some people. I just don't find it very noticeable. I'll give you a demonstration real quick. I guess you could consider it a little bit sharper, but I'll leave that one up to you. So the feedback point is basically where in this chain of inputs, per se, beginning, end, is it going to be taking the feedback from. Beginning meaning as soon as it enters in, it's taking feedback from there, feeding it back in, or towards the end, and it'll feed it back in from that way. So bring it back to 0. As you can see, it waits quite a while longer. It's kind of smoother as you get back up because it's taking longer for it to feed it back through, so you get more of the original signal. And then tone, finally, is wet or dry. It's just a wet control. Get an idea there. All right, let's go on to the more page where we'll get into the VCR and kind of tinker with that a little bit. So now we're on to the VCR. Time to whip out your old movies. Not really. But this stands for voltage controlled resistor. And basically it has these different types which changes the way the resistance works. So it's got either an exponential curve for the resistance, it's got either kind of like a JFET type, it's got either a linear type or a photocell type. And so when you go into the JFET and you change all these have the bias affects it, right? But exponential, the bias is pretty prevalent, and the exponent right here is what changes that. When you're at 0, that's kind of default bias. That's kind of where in engineering you want your bias to be right around 0, maybe a little bit off in order to make it sound better. But as you can see, it gets bland at the 10 and -10 areas. But at around 0, a little bit off, it sounds pretty nice. And then the exponent is, well, it's the exponent of the exponential, so e to the something, right? And then the higher the number, so it's basically changing the way this resistance works. And then inside some equation, it alters it. That's what the exponential is about. And then the JFET bias is really kind of prevalent here. I kind of liked it around -300-ish. It's got this weird kind of like X-Files type vibe going on. And so you can see the exponent doesn't change anything because it's specifically for the exponent. Linear, it's a linear, so just straight on. A lot of pedals use this. That's what's going on there. And then finally, photocell, where bias still affects it, I believe. Exponent doesn't, but attack and release does. The standard is 5 milliseconds, 35 milliseconds, but we can try to see what goes on when it happens when we change. All right, if you could tell a difference, great. I really couldn't see much. I see a little bit smoother as you get the times all the way up, but that's about it. I'd recommend messing with these some more, but the whole point of this is just so I can tell you what's going on. That's it for now. So let's not get this video any longer. I appreciate you guys sticking around if you did. If you made it this far, next week I'll probably be doing another tone hunter and also making a short video about the mixer just because I've got this here. I'll be slapping this preset inside of my my Patreon. If you're interested in that, link down below. But I appreciate you guys coming again. I'll catch you all on the flippy floppy.